All right, we're doing good. Next step is data mining. Listen, man, data mining is just finding data. That's basically it. Purpose is used to improve decision making by finding useful patterns and insights from data. Yeah. It's in the previous video I described basically high-level data points, and I was talking about metrics. For example, what's our growth metric this month? And it probably has something to do with how much we're selling, what are the costs and how we're handling the costs, what different markets we're connected to, and basically all data that's associated or that's transformed into readable data, or at the very least transformed into simple data points. How am I explaining this wrong? Right? I have no idea how I feel every company kind of like measures growth, and I use growth maybe specifically because what is the thought around growth? But hear me out. If I am going to be using data mining, or I'm actually looking at, or if I'm looking at kind of like describing something in the real world through data points, there probably has to be basically individual data points, and then a combination of them, and then another combination of them, and ultimately all of them kind of result in one thing, right? And I feel it's funny because ultimately, like we're very biased towards what we're working on. So the goal is always to kind of compare with where we want to go and if we're getting there or not. And we also have to put the rules and regulations of what makes sense or not. So look at it this way. I have to assign my own rules, assign my own metrics and data points that I need to collect, assign the formula and how to connect them, and ultimately assign where they should lead me. All of that is up to my basically, what's it called? Purview. Isn't that what a fucking data analyst does? Or a business analyst does? Kind of decides if you want to do this, you have to do it, or we're gonna do it this way or attempt that way. So you're always kind of like creating your own logic and building on top of that concept or context. Description: data mining is an analytic process that examines large amounts of data from different perspectives and summarizes the data in which way a useful pattern and relationships are discovered. Let's take a school, for example. How many people dropped out? How many people failed? How many people didn't pay? All of these are data points, right? And like ultimately the school would be like, hey man, we're for whatever reason we're having a lot more people fail to pay, so maybe we're attracting people that are not able to pay, so maybe we can split the school into like a certain structure that's affordable, a certain structure that's more kind of like highlighted. So instead of the intensity of the school, we could kind of do 2 layers or something like this. I don't know. I'm really thinking like a business analyst right now. It's like, what does it mean for you to kind of like split structures? Anyways, these models can basically be, results of data mining techniques are generally mathematical models or equations that describe underlying patterns and relationships. These models can be deployed for human decision making through visual dashboards and reports, or for automated decision making systems through business rule management systems or in database deployments. You get it? Like, you know, the models can be made from data to human, like can be deployed for human decision making through visual dashboards and reports. Like you see those charts, and every once in a while, every time they're trying to describe finance to you, they show you lines connecting and charts and movements and all that shit. That's what I'm talking about. And for automated decision making systems through business rule management systems or in database deployments, basically, right? So like a system is a lot more technical. So like, you know, if you're working with, let's just say, high-level stakeholders and low-level stakeholders. Low-level stakeholders are the stakeholders within the detail. So data mining can be utilized in either supervised or unsupervised investigations. In a supervised investigation, users can pose a question and expect an answer that can drive their decision-making. Like, what do we need for us to kind of like have X amount of sales on a yearly basis? Oh, we need certain data points about this market, we need this about this market, right? And then from there, you kind of like dive into what you're kind of like planning. An unsupervised investigation is a pure pattern discovery exercise. Unsupervised is, I feel like it's a lot more visual. You kind of do combinations and see if there are patterns happening. Charts kind of like do that. Selling points do that, up and down, whatever. Like data mining is a general term that covers descriptive, diagnostic, and predictive techniques. If you think about it, whenever we're looking at, like, for example, finance charts, we're looking for these patterns. So we're technically data mining without actually, like, you're data mining upwards or downwards if you want to make a decision to buy or sell. And that's where it kind of comes to, I don't know, that's where the playing kind of comes to it. Such a clustering make it description. Data mining is a general term that covers descriptive, diagnostics, and predictive techniques. Don't worry, it's just salt, man. It's salt. Diagnostic predictive techniques. Descriptive techniques such as clustering make it easier to see patterns in a set of data, such as similarities between customers. Why don't they have an example for us? Here, let's do it. I'm looking for data clustering examples. I just want to show you. Right? See, that's basically how clustering works. And these could be, I don't know, these are variations of everything. These are political clusters, North Carolina, South Carolina, something like that. I have no idea. I don't know, it's just fucking, this is how a cluster would look like. So imagine like data points. Imagine age groups that kind of are doing, I don't know, skateboarding, and then you kind of like see most clusters are around like 15 or 18-year-olds. And then, I don't know, right? That kind of shit. Diagnostics, such as decision trees or segmentation, can show why a pattern exists, or such as the characteristics of an organization's most profitable customers. Predictive, such as regression or neural networks, can show how likely something is to be true in the future, such as predicting the probability that a particular claim is fraudulent. You can use past data to develop patterns in order to see if in the future something kind of like, that's showing the same pattern might end up with the same result. Yes. We are still predicting, though. We don't really make assumptions, but we prepare for them. I think that's the healthier approach. In all cases, it is important to consider the goal of the data mining exercise to be prepared for considerable effort in securing the right type, volume, and quality of data with which to work. Cool beans? All right. Now, what are the elements? Well, the goal and scope of data mining is established either in terms of decision requirements for an important identified business decision, or in terms of a functional area where relevant data will be mined for domain-specific pattern, right? Like, you have to get information for why you're doing this, because there's a fuck ton of data, and we're talking Googles and Googles of data, petabytes of data. It's fucking like ridiculous. It's ridiculous. There's just data on everything, everywhere. So this is a top-down approach, because you kind of like decide what you want and you can look for the data, versus a bottom-up mining strategy. A bottoms-up mining strategy allows analysts to pick the correct set of data mining techniques. What? I feel like I missed something. Or in terms of a functional area where relevant data will be mined for domain-specific pattern discovery. Like, if you're looking for pattern discovery, you start with what you want and then you find that data for it. Bottom-up approach is more like, let's look at this data and see where it goes. And then if you follow the data, then ultimately you kind of like understand something later, further on in the structure. Formal decision modeling techniques, C decision modeling, are used to define requirements for top-down data mining exercises. For bottom-up pattern discovery exercises, it is useful if the discovered insight can be placed on existing decision models, allowing rapid use and deployment of the insight. Data mining exercises are productive when managed as an agile environment. They assist rapid iteration, confirmation, and deployment while providing project controls. They're productive when managed as an agile environment. They assist rapid iteration, confirmation, and deployment while providing project controls. Data mining exercises are productive when managed as an agile environment. They assist rapid iteration, confirmation, and deployment while providing project controls. Yes, they are supportive. We have to look at them that way. It's like when you're mining for data in order to kind of support your case or kind of prove your case, or best case scenario, like kind of like, what's it called? Not prove, not confirm, but kind of like small. Prove your case wrong. It's always much better to prove something wrong than to prove something right, because like you can never prove anything right. You can always kind of like get closer to it actually being the right thing, but proving it wrong means you don't have to look at it anymore, or you can look at something different or look at the same thing from a different angle. Data preparation, analytical data set. Why did they do it that way? Data mining tools work on analytical data set. This is generally formed by merging records from multiple tables or sources into single wide set data sets. Right, like they're talking about records, which we used to store before. And all the data points that kind of like are transferred from department to department and where they're stored, because each department stores them separately. And ultimately the data may be physically extracted into an actual file, or it may be a virtual file that is left in the database or data warehouse so it can be analyzed. Analytical data sets are split into a set to be used for analysis, a completely independent set for confirming that the model development works on data not used to develop it, and a validation set for final confirmation. Oh, sorry, man. I'm so sorry. I started thinking of working on a project, and it took me all the way to when I was taking a boot camp and was thinking of data. Data mining tools work on analytical data set. It's generally formed by merging records from multiple tables and sources into a single wide data set. Records, man, ultimately, like, you know, every system kind of is connected through an API, or at the very least, like, you know, this is a place that has tables, it has chairs, it has basically walls, right? All of these are data points. When you're thinking conceptually when it comes to a business, or in the context of a business or an enterprise, you're thinking of that. You're thinking of all the different kind of like things that go into the business, or all the different things that the business uses. Operationally, logistically, salesy, whatever the fucking case. So the data repeating groups are typically collapsed into multiple sets of fields. That's what we call normalization of data. And so ultimately, like, you know, think about it, Tariq touched this, and then Tariq touched this, and Tariq touched this, like, and Tariq touched this, like, you know, Tariq is common in between them. So Tariq is put somewhere, and every single one of them is put separately and connected to Tariq, because I'm Tariq, by the way. Tariq is connecting to these. So the data may be physically extracted into an actual file, or it may be the virtual file that is left in the database, or data warehouse so it can be analyzed. Analytical data sets are split into a set to be used for analysis, a complete independent set of confirming that the model developed works on data not used to develop it, and a validation set for final confirmation. Data volumes can be a very large, sometimes resulting in the need to work with samples or to work in a data store or on a data not have to be moved around. And look at it this way, again, like we're data mining, right? So what are we doing? We're looking for data points. So like, you know, I have interacted with this place, and there are a lot of data points about my interaction with this place, but I also interacted with 3-4 different places. And what they're saying here is they're kind of like there's warehousing structures, because you're taking data, but there's data that's already there, but you have to separate it in a way and kind of contextualize it in different spaces. And sometimes you have like a whole lot of like information that you have to visit differently. Or maybe you want to look at certain states that I was in when I was like, where the certain times of days and where I visit, for example, in order to make a decision around when do I do an advertisement for a man. Like, okay, let's use e-commerce. The heaviest slots that cost the most money when it comes to, for example, like when it comes to advertising on Instagram and TikTok, are basically between the hours of like 4 to like 7 at night, and between the hours of like 12 to like 2 in the day. Why? Because that's when people take breaks, and that's when most people play with their phones, and that's where people are most kind of like, scrolling. So like, imagine what data. Imagine if I want to kind of like create an advertisement, I will need that data. So Instagram does it for me instead of me getting data on all the people on Instagram and like reassembling them in a different way. But anyways, so that is a bit more, I don't know how to explain it. No, I have not figured out how to explain it. That's basically like complexities resolved in order for you to be able to build on top of them. And that's, I think, what they're talking about right now. Because like here, data volumes can be very large, sometimes resulting, because we're talking about analytical data set. We're preparing the data. And what we're doing is we're creating basically, here, look at the data may be physically extracted into an actual file, or maybe a virtual file that is left in the database or a data warehouse. So it could be on a server or a file with you, a paper. So it can be analyzed. Analytical data sets are split into the set to be used for analysis, and completely independent set of confirming that the model developed works on the data and not used to develop it, right? Because like the last thing you want is to kind of like, is to build a model and to kind of like use the data to develop it. You need to build a model that works on the data that you have instead of like build a model from the data that you have. If you build a model from the data that you have, then what you're doing is you're building a biased model, right? But if you're building a model that works on the data that you have, then the model kind of like has your hypothesis, and then it theorizes, it becomes a theory based on the actual data that it received and what comes out of it. And here they're talking about like, and a validation set for final confirmation. Wait. And a validation set for final confirmation. So data volumes can be very large, sometimes resulting in the need to work with samples and to work in data store, so that the data does not have to be moved around. They're just kind of like telling us about data and all that good stuff around data. And data might be too much. Yay. Data analysis. Once the data is again, like for these seem intuitive to me, or maybe because I'm explaining them out loud, right? But like I very much don't like the fact that they're describing everything in such fucked up details. I don't know. I'm sure it's necessary. I believe it's necessary. It's just frustrating me. Once the data is available, it is analyzed. A wide variety of statistical measures are typically applied, and visualization tools used to see how data values are distributed, what data is missing, and how various calculated characteristics behave. This step is often the longest and most complex in data mining effort, and is increasingly the focus of automation. What are we talking about? We're talking about how we handle the fucking data, and the plan that we have for analyzing that data, and the feedback loops that we're getting out of the data, and what the model is actually doing and coming back to blah, 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 blah. Much of the power of a data mining effort typically comes from identifying useful characteristics in the data. For instance, a characteristic might be the number of times a customer has visited a store the last 80 days, as I explained earlier. Determining that the count is over 80 days is more useful than the count over the past 70 or 90 is key. I have no idea. If somebody comes once a month or if somebody comes 3 times a year, right? Those are different data points, or at the very least, those are different use cases, I guess. There are, lahza. Maybe coming 3 times a year means they're a lot more seasonal. It defines something different. So there's no better data. There's what is the data going to be used for. All right, that's what I'm talking about. Modeling techniques. There are a whole variety of data mining techniques. Some examples of data mining techniques are classification and regression trees, and other decision tree analysis techniques, linear and logistic regression, neural networks, support sector machines, and predictive scorecards. All of these are basically like, I hope they're actually being taught here, are going to be taught here over the next small. I think we still have like 35 techniques. I hope these are some of them are explained here. The analytical data set and calculated characteristics are fed into these algorithms, which are either unsupervised. Remember unsupervised or supervised, right? Unsupervised, as in like I have no idea what I have, let's see what I can make out of it. Or supervised, the user is trying to find or predict something specific. Multiple techniques are often used to see which is most effective. Some data is held out from the modeling and used to confirm the result that is replicated with data that was not used in the initial creation. So here basically like we're kind of like, sometimes we take data and we create the model and we see the outputs of the model, and then we kind of like look at data that actually worked before or something like this and we compare. Some data is held out from the modeling that used to confirm that the results can be replicated. All right, so basically if I have a fuck ton of data, I don't use all of it in order to create a model. I use some of it. And the goal behind that is to test the model after we're done with the data that we haven't actually seen, right? I think this is kind of, in journalism, they call it red team. What they do is they kind of like work on a piece and they kind of like get a red team. And the red team is the blood test, is they kind of like ask the questions that other people are not small. Ask the questions that other people are not very, that removes people from their biases. And once a model has been built, it must be deployed to be useful. Data mining models can be deployed in a variety of ways, either to support a human decision maker or to support automated decision-making systems, of course. Why would I build a model? In order to understand better, make it simpler, easier, smoother, more direct, whatever the case. For human users, data mining results may be presented during visual metaphors or as simple data fields. Many data mining techniques identify potential business rules that can be deployed using a business rules management system. Such executable business rules can be fitted into a decision, like a model comes with rules, with whatever, with operational like instructions. They're saying the business rules can be fitted into a decision model along with expert rules as necessary, because you have here is a data model, but you have a decision model. So the data that you're getting go into the decision model a certain kind of way so you can take decisions out of that model. Or you have a better environment to be taking decisions from, right? Some data mining techniques, especially those described as predictive analytic techniques, result in mathematical formulas. These can also be deployed as executable business rules. It can also be used to generate SQL or code for deployment, which create KPIs, right? Because that's what we do. Like when you create a model, you go like, okay, so this is a KPI we can use. An increasingly wide range of database deployment options allow such models to be integrated into an organization's data infrastructure. Usage considerations, strengths reveal hidden patterns and create useful insight during analysis, helping determine what data might be useful to capture or how many people might be impacted by specific suggestions. That's what it does. It kind of like, it shows you the hidden patterns, because like when you're building a model, you're kind of like deciding how the data would go or how the data would be used. And it kind of shows you where our thoughts are not really connecting with what we're trying to do, because ultimately we're using this data for a reason, and the model kind of links it, or at the very least gathers the information that we need, that we get from mining, in order to put it somewhere. So yeah, we are modeling though, we're not mining. Can be integrated into a system design and increase the accuracy of data. Can be used to eliminate or reduce human bias by using the data to determine the facts. Okay, like, yeah, so like, again, human bias, right? Because what are we talking about? We don't want to build based on the data. We want to use the data to kind of like confirm or deny what we're building. And the limitations are applying some techniques without the understanding of how they work can result in erroneous correlations of misapplied insight. That's what happens most of the time, because a lot of people just kind of like take data and then use it based on what they think it's pointing at, but ultimately it might be pointing at something completely different. So the models they have are normally just, I don't know. Anyways, access to big data and to sophisticated data mining tool sets and software may lead to accidental misuse, and it's costly. Many techniques and tools require specialist knowledge to work with. Yes, you need kind of like people that have an idea what they're doing and how they build data. Some techniques use advanced math and background, and some stakeholders might not have direct insights of the results. That's why there are softwares that do that, man. And data mining results a perceived lack of transparency can cause resistance from some stakeholders. I completely understand that, because a lot of people go like, I have no idea what I'll be doing, so what the fuck is going on? And ultimately, data mining results may be hard to deploy. The decision making they are intended to influence is poorly understood. So we're still talking about data mining here. We're still at 10.14. And what we're talking about is modeling our understanding, right? We're talking about the modeling techniques that we would use in order to kind of like get the data we want. And in 10:15 right now, we're going to be talking about data modeling. So fuck yeah. Yay. Love you guys. Wow, 25 minutes. That was intense.